sample size for the proportion. When instead of the sigma, if we have a proportion, what should I do? Is again, this formula came from the same thing. So for proportion, the margin of error has a z value, right, times square root of the pi 1 minus pi over n, right? So I can do the same thing if you just multiply the square root of n e equals z times square root of pi 1 minus pi, and you divide by e both sides, so it's n z square root of pi 1 minus pi divided by e, right? And now I'm take a square both sides, so n is a z over e square, because you can take it out, and then this one will becomes pi 1 minus pi. So that is this formula. So now how can we estimate the pi? So you assume the pi is 0.5. This is a very conservative way. Why this is conservative way? Here formula with z over e square, and then pi is 1 minus pi. So this portion, because this portion doesn't have affected by pi, and then this one, if you draw the graph, this will be this graph. So this is if you change it to the x is 1 minus x, which means this is x minus x square. If you plot the y equals x minus x square, the solution is 0 and 1, so 0 and 1, and this is minus square, so the graph will be something like this. So highest point will be when this is 0.5. So when we assume pi is 0.5, I don't know what is the real pi, but 0.5 will create the biggest n. Right? That's why this is a conservative way. You assume the pi is a 0.5, and that will generate the largest n. That is a conservative way. The other one is you can just take a preliminary sample, and then you can estimate what is the p, and you can use that proportion, and then you can calculate the n. The other one is the if you have like a historical data, or somehow there's some information is given, then you can use. So this is another example. University Credit Union want to know the proportion of cash withdrawal that is more than 50%. More than 50% cash withdrawal. What is the proportion of the greater than $50 cash withdrawal? So with the error of the plus minus 2%, and the confidence level is 95%. So I want to have an alpha is 0.05, and the error, I want to have an error is 2%, which is 0.02. To make this happen, how many n do I have to use? So you have to look for the z value that with the confidence level 95, so that's the 1.960, and then e is given, right, because it's a 2%, so it's a 0.02, and then square. Now I don't know what is the proportion, so you can use a conservative way, because that will create this part the maximum, right? So you can just plug in 0.5 and you can calculate it, then you will need a 2401. So this case is we are not assuming just 0.5. We have a last year's proportion. Last year proportion was 27%. So you just plug in the 27% and here, and as you can see, this is smaller than the previous case, and you can use this historical data or some information from somewhere. So pi, assuming pi is 0.5 is actually the maximum number, maximum you can get. So far, we take a look at the x bar and the proportion. X bar case is when the standard deviation, population standard deviation is known, and population standard deviation is unknown, and x. And then we also look at how we find out the required number of sample size. However, what if I want to have a confidence interval for variance? Or standard deviation? Can I create the standard confidence interval for the standard deviation or the variance? Then we have to use the chi-square distribution. So chi-square distribution is used some otherwhere, but in our course, this is the way. Upper number and then the lower number. This is upper number, this is lower number, chi-square, and then you will create the confidence interval for the variance. Okay, so standard deviation, you can just take a square root both sides, right? Just square root. Then you can just simply get a confidence interval for the standard deviation. Confidence interval for the variance here. This is for the variance. But now how can I find out the chi-square distribution? Let's take a look at the pizza delivery. So a particular Friday night, charge for the 40 pizza delivery. So you gotta order Friday night. So we collected a sample of 40. But how much we charge for the one pizza delivery is mean is $24.76 and the variance is 12.77. So we want to construct the 95% confidence interval for variance, not X bar anymore, right? So sample data is nearly symmetric with no outlier, so normality will be assumed. But this is kind of important. X bar, when the sample size is bigger, X bar will be normal distribution, even the population is not normal distribution. However, we don't know about the standard deviation here. So we can just assume the normality, and then using appendix E, this is the chi-square table. Using the degree of freedom, again, this is n-1, so which is 39, and we want to create the 95% confidence interval, so we can look up the chi-square. So 95, again, this is the area upper tail, right? So doesn't matter what this looks like. Upper tail, so if you want to have a 95 here, confidence interval, this is a 0.025, this is a 0.025, right? So if you want to find out this point, you have to look for the 0.975, and if you want to find out this point, you have to look for the 0.25, and then degree of freedom is 39. So you can find the two number here, 23.65 and 58.12. Now using this two number, again, this graph shows you, that's why this way in between, this is the 95%. That's why we are looking for here. This is all the way down here is 97.5, and then this is just 2.5, right? That's why we have to look for these numbers for the 95% confidence interval. And then once we got this number from the table, you just plug into the formula. You can find the lower bound and you can find the upper bound. So you can say the 95% confidence, again this is not a probability, but 95% confidence, we can say the variance of the population variance will be between 8.5 and 21 in between. Or if you want to talk about standard deviation, you can just take a square root of both sides. So 2.93 will be the square root of 8.569, and 4.59 will be the square root of 21.058. And this is for the standard deviation, and this is the variance. So we assume that everything is normal, right? So the method describes the confidence interval of the variance, and the standard deviation is the normal distribution, depending on the population having a normal distribution. If the population does not have a normal distribution, or is totally different than the normal distribution, actually there's no specific way to find out, and we have to use a bootstrapping, which means it's similar to the simulation. So no other analytical way by using formula to find out the normality. If there is no you cannot assume the normality, then you cannot have a formula for the confidence interval. You have to use some different way, computational method, like a simulation. Okay, this is the end of the chapter 8.